So this autumn, 56 AICC agronomists covering 42 counties helped us assess damage caused by cabbage stem flea beetle. So what I'm going to look at today is to look at thresholds, and in particular on the flea beetle ones, and also a few other thresholds which we're familiar with, and look at exactly how robust they are. Then I'm going to move on and look at the results from those assessments that the agronomists did and see how we can learn from some of their observations and how we can put that into practice and use it for the next years. So moving straight on to thresholds. I'm not going to talk about what exactly the thresholds are, but more about the background and also where they came from and what year, how robust they are. So I picked on slugs first, as it's been quite a bad slug year for some. So these thresholds are actually quite recent ones and are from 2009, so not too old. And they were based on the layers mash slug trapping method. And they can be quite complicated, so they can involve trapping in the previous crop, so before the crop's harvested, or when the new crop is growing. So you can actually implement different types of thresholds for that. So it's targeting the adults or the parents rather than the offspring of all the slugs which you're going to end up with. I put the unsure face there because of the metaldehyde issues. And we have started some more research which is looking at the spatial distribution of slugs and whether or not we can try and implement a more targeted control approach. So pollen beetle is another one I focused on. So the thresholds, as I'm sure you're aware, were updated in 2013. And this was to take into account the ability of the crop to tolerate the pest. So looking at the beetles per plant based on the plant population. And this is work which is ongoing, so we still have research being done at the moment on this to try and understand and learn more on how the crop is able to tolerate it. Orange root blossom midge, I thought I'd put a cereal one in there so the cereals don't get left out. So we've got two different thresholds. We've got the midges per ear, which was from research which ended back in 2003. So it's starting to get a little dated. But then we do have that pheromone trapping method, which was completed in 2009. So it's a lot more robust. And now, as well as those, we also have a lot more resistant varieties which can be used. Then moving on to the flea beetle. This is where things get a little trickier. So with the adult beetles, where it's based on the leaf area of damage, that work was actually done somewhere between 2001 and 2003, so perhaps not so robust. But the larvae work have done quite a bit looking at dissection, leaf scarring, and also water trapping, and that was most recently done in 2007. Flea beetle I'm going to focus on a bit more. And because you can see that the larvae work is done a lot more recently and the adult beetles is a little more uncertain, which one is actually going to cause the worst damage? And that's a question which we've been asking in the last couple of years, as historically, although adult beetles have been thought to cause serious damage, it's actually the larvae which have thought to be more important in the past. Unless the crop is backwards or slower growing. This particular statement I found from quite an old document from 1984 when I was doing some research looking back. However, going back from then all the way up to now, it was the same comments that I was seeing, that the larvae were the more damaging part of the cycle, until recently it seems. So if we look at those thresholds in a little closer, where they came from. So I'm going to start at the bottom with dissection, as this is the one which came in first. And when I looked back on the research, this actually came in the 1980s, this was looked at, and this was at 5 larvae per plant threshold. It was then re-looked at in 1994, and then again in 2007. In this time, leaf scarring was looked at to see if there was an easier way to look at the damage rather than having to cut up the crops. So this is where that more than half of the petioles damaged threshold came in. And then in 2007, it was looked at again, where research was done to see if there was an easier method using sticky traps or water trapping. And water trapping was the method that worked best. And this is where the new threshold of the average number of beetles per trap over the monitoring period came in. We did recently update it just this year, as it was previously 35 beetles, not 96, and the dissection to coincide with that was 2 larvae. But when I looked back at the research, this was based on effective use of pyrethroids, and also it was done based on the economics of the crop at that time. It seems counterintuitive to up it. This is because of where there's been more pyrethroids put on, also taking into account resistance, and where people are using alternative actives instead of the pyrethroids, which are more expensive. So if we look now at the adult beetle thresholds, I looked as hard as I could to try and find the source of where this threshold appeared, and all I could find was that it came in between 2001 and 2003, and as I couldn't find any papers to back it up, it seems clear that it was introduced more of a guidelines for those crops that did come into that more vulnerable stage, so backwards or slower growing, because back then it was always thought the larvae were the more important ones, so that's where all the research was done. And then the fact that if the crop is growing more slowly, then it's being eaten, well, this is more of a common sense thing. So there's what we think of that. And I put the mind the gap in there, as obviously this brings up a big question on what research needs to be done, looking more at the adults as well as the larvae, so we can understand the relationship between the two. So what we've been doing, we funded AHDB to do some work in 2013 and 14. So this looked at field trials as well as doing some lab studies looking at the defoliation of the crops. And in this work, they went right back from cutting off both cotyledons to punching holes, as you can see in the picture. And what they found from where they did these lab-controlled experiments were that even where both cotyledons were cut off, the crop managed to grow back. So it just highlighted the importance of the survival of that growing point is the most important thing. Then what we've done in the autumn of 2014 and 15, so the last 2 years, we've had AICC agronomists look at and do monitoring of the crops throughout the country, and AHDB have gathered the information and seen the effects that the beetles have been causing, and then in some instances we've also gone back and looked at how the larvae have been damaging the crop. So this has been done on a national scale, and we're also able to assess it down to regional level and then also break it down further to county level. We also asked them to do different observations as well, so we could try and learn to see what factors might be affecting the crop's ability to withstand it. And then as we've identified a lot of gaps in research, this is where we're hopefully going to try and do some more research to answer a lot of the questions that we all now have. So I'm going to start with looking at some of the larvae effects that we saw, looking at some of the sites which were worst affected in 2014 from the assessments that were made at the autumn of that year, and the counties which were carried forward and looked at and how the damage had affected them through the larvae were Bedfordshire, Cambridgeshire, Hertfordshire, Suffolk, Surrey and Hampshire. So what they found is that the larval populations did correlate with the adult damage, which supports some of the older research that I found, but it answered a lot of questions as well. So we found that most of the larvae were actually in the leaf petioles rather than the main stems, and this was in most cases, except in counties, for example, Cambridgeshire, when the larval populations were so large. The average yield reduction was about 0.5 tonne per hectare. This was based upon what the farmer had recorded himself and based it upon his 5-year average. But they did find that there wasn't actually a correlation between the larval numbers and yield. So a lot of questions opened up there. So what we've done this year is, again, we've asked the agronomists to look at a nationwide look at the cabbage stem flea beetle damage. And this covered about 62,000 hectares, which is about 11% of the UK area. So I'm going to talk through some of the preliminary results, as this report isn't actually out yet. So first of all, what they did is they carried out assessments at the cotyledon to 2 leaf growth stage, once about 3/4 of the crop had reached it. And then the second assessment they did was at the 3 to 4 leaf growth stage. So this ties in with those guidance thresholds that we looked at. So the results that we got on a national level, on the severe damage, which is where the 1% is, it was about 5,000 hectares which were lost to cabbage stem flea beetle on a national scale. And then the high and moderate damage, if you put those together, that is what at that point the threshold would be. So if you add those up together, if what would exceed those thresholds we've got, it's about 22% at that time, so at the cotyledon to 2 leaf stage. Then at the second assessment, which was the 2 to 4 leaf stage, again it was about 1%, but it was actually a little higher, so this is rounded up, and it was about 6,000 hectares which had been lost to the flea beetle. It's also worth noting that at the first assessment, at the first and second assessment, we also asked about losses for other reasons. And at the first assessment, about 1.9% of the crop had additionally been lost to other reasons, and most of that was put down to slugs. And at the second assessment, just over 3% of additional crop was said to have thought to been lost. And again, that was other reasons and mainly down to slugs. At this assessment 2, the threshold again changes a little bit. So it was about 4% at this time that was thought to be over that threshold. And many of the agronomists stated that in many areas the pyrethroids or the control they had applied had an effect, which they thought this had affected why by this point the damage levels had changed. So if we now narrow it down and look at a more regional level, you can see the areas which are most affected are the east, so across from Yorkshire and Humber, northeast, East Midlands, West Midlands, east, southeast and southwest. So it's quite a wide spread of damage. The darkest red is where the losses were, through to the amber is where thresholds levels, so that's up to more than 1/4 of leaf area damaged. And then the blue and the green is where it gets less after that. So in the southeast and the east, which were the worst at this time, it was about 1.7% loss for the southeast and about 1.4% for the east. And then this changes assessment 2. There's more green on this one as it's based upon those thresholds again. So the oranges on this chart are where there's more than half of the leaf area lost. So again, this is more focused particularly on the east at this time. So you've got the damaging where the crops are becoming worse at this period. So you've got Yorkshire and Humber, East and West Midlands, East Midlands, East and Southeast. And again, it was the East and Southeast which came up worst. The East had 2% crop losses, and then the Southeast about 1.7%. So if we narrow this down and look more at the county level, so first of all, I decided to look at this at the assessment phases where the thresholds were exceeded. So you can see it's quite a huge area at that assessment 1. But moving on to assessment 2, this is when it starts to narrow down and push towards the east a bit more, where the crop is less able to grow away from the damage. But if we look at the map again in terms of loss, this shows up a bit more of where the more vulnerable areas are. So bucks actually came up highest at about 9% of the crop lost. This is something we're going back to those agronomists to find out exactly what they thought was going on in this county. Assessment 1, Cambridgeshire, also came up as a hotspot. And then at assessment 2, more losses cropping up in places like Essex, Cambridgeshire, and also East Yorkshire. Other things we also asked was about the crop susceptibility. So one of the key things that we asked them was about the drilling date. And what they came back, so 70% of agronomists observed an effect related to the drilling date. And not surprisingly, most came back that they thought earlier drilling was better as the crop was able to get away before the migration of the beetles came in. Those who said that mainly came from the east, so it was agronomists from the southeast all the way up the band up to East Yorkshire who noted that. This was not the case for those agronomists which were in the northwest, and this is thought to be because their early drilling was actually later drilling for most of others, so they were drilling a bit later on, later August, early September, so it was more coinciding with the migrations. Soil type was something else we asked about. So just over half of the agronomists observed an effect. So there's quite a difference in what they saw here, and this is mainly looking at soil rather than the moisture. So the more susceptible they thought was to do with the poor seed beds, and also where there was heavy clay or cloddy soils, and also chalky and limestone soils, for example, counties such as Essex, parts of Yorkshire, and also Lincolnshire. Less susceptible, again, so the better seed beds, and light and fine soil. I say light and fine soil, but in some instances where it was drier, this was not the effect. So this is if moisture was at an optimum. So moving on to the weather, it was nearly 60% saw an effect here. So conditions they noted, for example, were warm and dry, where they thought it was better for the quicker establishment, but there was more cabbage stem flea beetle activity. Cool and wet tended to reduce the flea beetle activity, but if this kind of weather conditions were experienced at drilling, they thought the crops were much slower to grow, and therefore it made them more vulnerable when the weather turned. Wind was something else which came up, as I thought in the more calmer conditions allowed the beetles to move around the crop a lot more and for those migrations to come in. And this was also identified as something around coastal areas, so they thought that there was potentially less beetles in these areas which could have been attributed to the wind. So they also noted some other factors which it's worth pointing out. The first one was rolling. So the seedbed quality and consolidation, so enabling the crop to get a better start. Other one was the spray conditions, so if they were going out and spraying, to spray when the conditions were optimum for the pest, so when it was dry, warm and still. So there was more pest activity, they've got a better target. And the other was where the previous season's oilseed rape was, and also growing a crop where there was worse flea beetle attacks in the previous years. So the proximity. If we look at what we've learned from the last few years then, in terms of the areas first, so this is the worst affected areas we identified from this year. And then if we look back at what we had last year, so this is where the different counties which experienced losses last year from those ADAS assessments, with the worst being in the east. And then I looked back to the 1984 report, and the counties it highlighted as areas of importance, actually not too dissimilar to what we're seeing at the moment. So it does show that even back then we did have some knowledge of those key areas where the pest could potentially cause considerable damage. So I put these 3 years together and trying to put together lessons we've learned which we can take away and use for the future. So we know a lot about the regional spread, the sites near previous infested crops, something worth bearing in mind when putting the next crop in. Early drilling by mid-August was something which was even noted in that paper from 1984, so relaying messages. The fine seed bed, no clods, slow crop growth was a bad thing. Warm and dry weather, again, favoured the pest, but it could also help growth, so the pro or con, the same with cooler wet weather, and also those still conditions of no wind. And then spraying in the conditions where the flea beetles are more active. So tying these in with your monitoring, we could hopefully get a better idea of how to deal with the pest for future years. So if we look at what's the point of the thresholds in all, well, the point of them is the assessing risk. So if you go back to that risk and resilience, the thresholds are so you can assess that risk, and so there's less regret at the end of the day, and you can rely on those thresholds. So the reliable thresholds that we do have, some of those that I pointed out, are the slugs, pollen beetle, the blossom midge, and the larvae. But it's the adult beetles where a lot of more work needs doing, looking at the thresholds. But we do have the monitoring, so looking in the previous crop grain store, knowing what previous crops have suffered, the experience of the last few years, and looking back at previous years as well, even going back, like I did, back to 1984. So using this monitoring and experience can help us hopefully grow a better crop in the years to come. Thank you.